An interesting experiment can be done with an envelope detector, which demonstrates its operation and is a first step into the fascinating world of radio communications. The simplest of all radios is called a crystal set, and a typical setup for one is shown on the screen. Let's have a look at the individual parts one by one. We have already covered parallel tuned circuits in video 20. This circuit allows all frequencies to pass through except one, which is given by the formula shown on the screen. So it is ideal for tuning in a radio station, since all frequencies pass through the circuit to earth except for the one we've selected, which goes to the envelope detector. The operation of the envelope detector itself was covered in detail in the last video. However, one important point is that the diode used should have a low forward voltage drop so that small signals can be heard. Therefore, a germanium point contact diode can be used. Suitable types include IN34As or OA91s, but most other point contact types can be used, and you can get them from Amazon or from an electronic supply company like Maplin, Radio Spares or Farnell. Similarly, the other components are available from these companies and suitable types are shown on the screen. In the case of the tuning coil, you can buy one assembled already, which has circuits for medium wave and long wave, or you can wind your own with about 100 turns on a ferrite rod. Use copper enameled wire, which is insulated. For the envelope detector RNC, suitable values might be 47K and a 0.001 microfarad capacitor. But quite often these components are actually not required because the parasitic resistance and capacitance from the other circuit components is sufficient to smooth off the envelope. A circuit like this without RNC is shown on the screen. And now we come to the earpiece. You may have noticed something amazing about the crystal set circuit, and that is that it has no source of power like a battery. All the power actually comes from the radio signal itself, and because of this, a very sensitive earpiece is usually required. The normal moving coil type of earpiece is just not good enough. Crystal earpieces use the piezoelectric effect to operate, and are many times more sensitive than standard earpieces. Sensitive enough to be energized by even the tiny power coming from the unamplified radio wave itself. Such earpieces use a crystal of barium titanate or quartz to produce their sound. When such a crystal is subject to an electric field, for example from the radio signal, it physically deforms and so displaces the air, creating sound. Even with this super sensitive earpiece, you will often need to sit very quietly in an isolated room in order to hear the radio station. An excellent antenna and earth are also required for the set to operate correctly. The earth can be made by driving a copper pipe into damp ground as shown on the screen, or by using another suitable earth connection if one is available. The antenna should be as long a piece of wire as possible, placed as high above the ground as is practical. Once you have a radio working, you can experiment endlessly with different setups. For example, try different types of diode, silicon, Schottky, germanium, or try some of the older historical types of detector which you can look up on the internet, like the cat's whisker type. You can also make cat's whisker detectors, for example from iron pyrites crystals or even lumps of coke. Different coils and capacitors are also interesting to experiment with.